So we are now at question 7, the first 3 figures in the sequence of shapes. So draw figure 4. So figure 1, notice, figure 2. So figure 4 we simply just add. So figure 4, this is figure 3, so figure 4 will look something like this. Just add 1. So just add 1 to this. So figure 4 should resemble something like this, right? Figure 4. So notice figure 1 is 1 of this shape. Figure 2, 2 of the shape. Figure 3, 3, and figure 4, of course, would consist of 4. Now, we're asked to copy and complete this table. Copy and complete this table. So figure 1, number of lines. Figure 1 has 6 lines and the perimeter is 5. So what's the relationship between the figure 1 and number of lines? The relationship I'm seeing here, to move from figures to number of lines, you multiply the figure by 5. You multiply the figure by 5 and add 1. So 5 times 1 plus 1, that's 6. 5 times 2 plus 1, that's 11. 5 times 3 plus 1, that's 16. 5 times 5 plus 1, that's 26. So to get this, of course, you'll remove 1. Remove 1 from the 66, you get 65. 65 divided by 5, that's 13. And to check it, 5 times 13, that's what? 55 plus 1, that's 66. So this is 5 times n plus 1. What's the relationship between the figure and the perimeter? I'm seeing you multiplying the figure by 3 and then add 2. So 3 times 1 plus 2 you get 5. 3 times 2 plus 2 you get 8. 3 times 3 plus 2 you get 11. 3 times 5 plus 2 you get 17. 3 times 13, that's what? 39 plus 2 get 41. So it's 3 times the n value plus 2. Part C, write a simplified expression in terms of n for the difference d between number of lines and the perimeter. So let me go back to the table. Difference between number of lines and perimeter. So notice number of lines is 5n plus 1 and the perimeter is 3n plus 2. So 5n plus 1 minus 3n plus 2. So 5n plus 1, that's the number of lines, and 3n plus 2, that's the perimeter. So d, simplify, 5n plus 1 minus 3n minus 2. You group the n, you get 5n take away 3n, that's 2n. And 1 minus 2, that's minus 1, right? So d is equal to 2n minus 1. So section 2, Marla buys 2 types of mobile phones, B-Flow and C-Flex, from a company to retail. One B-Flow mobile costs $60 and one C-Flex costs $80. She buys X number of B-Flow, so X number of B-Flow, and Y number of C-Flex phones, right? Marla must not spend more than $1,200. Write an inequality to represent this information. So she buy 2 types of phone, B-Flow and C-Flex. So one B-Flow costs that, while one. So she's buy X amount of B-Flow and Y amount of one. So Marla must not spend more than $1,200. Write an inequality to represent this information. So C-Flex, so B-Flow represented by X number of B-Flow. So B-Flow represented by X and C-Flex represented by Y. So the total cost. So one B-Flow mobile costs $60. So 60x and the c flex 80 plus 80y, and the summation of these two total, it must not be more than 1200. So it has to be equal to 1200 or less than 1200. So that's the first inequality. The number of B-flow phones must be greater than or equal to the number of C-flex phones. So B-flow was X, right? So the number of B-flow phones, X, must be greater than or equal to the number of C-flex phones, which is Y. Remember, B represented by X and the C-flow represented by, C-flex represented by Y. That's the other inequality. Represent the two inequalities on page 22 on the grid shown below. Label as R the region which satisfies both inequalities. Alright, so let me do the second one, this inequality. Of course, we'll draw the line x equal to y. X equal to y. Let me draw this line. X equal to y. Alright, is that line where the x and y coordinates are the same. So it would pass through 5, 5, 10, 10, and so on. Alright, so this line would look something like that. I don't have a ruler, so I'm using freehand. Let me just, another point would be 15, 15, right? 15, 15 would be another point, alright? So there lies a straight line. This is a line x equal to y or y equal to x. And of course, the region we're talking about, x greater than or equal to y, would be this region here, alright? The region below the line. Okay. The other equation, the line which represents this equation will be, so 60x plus 80y, let's draw this line, 60x plus 80y equal 1200, that's the line we'll be drawing. 60x, let's draw the line 60x plus 80y equal to 1200, a very easy line to sketch. We want to know where the line cuts the y-axis. You can let the 60x be 0. Let x be 0. So if x is 0, you'll end up with 80y equal to 1200. And if 80y is equal to 1200, you'll divide both sides by 80 to get y. So you'll have 1200 divided by 80, which is 15. So this line, it cuts the y-axis at 15. And to get the point where this line cuts the x-axis now, you will let the 80y be 0. And if 80y is 0, let y be 0, which means 80y will be 0. So you're solving the equation 60x equal to 1200. And if 60x is equal to 1200, divide both sides by 60. So 1200 divided by 60 is 20, so which would be here. So you cut the x-axis at 20. Alright, so you cut the y-axis at 15, x-axis at 20. Let me see if I can draw a line. Just to connect these, alright? And it's supposed to be a straight line. Of course, in an exam, you will use a ruler, of course. Alright? So the region, the less than, so this will be the region. Alright. This is a 60x plus 80y equal 1200, that's a line. And the inequality says less than, so it will be under the line. Alright. And of course, the other one will be under the line again. X is greater than or equal to y. Same as saying y is less than or equal to x, which means that this would be the region, shaded region, representing both inequalities. Alright, there's another section to the question. So it's a shaded region, right? The total number of mobile phones is represented by x plus y. According to the graph on page 23, what is the largest possible value of x plus y? Let's go back to the graph to see if we can find the largest possible value of x plus y. Alright, total number of mobile phone, x plus y. Alright, so it would be, well, I guess I need a more accurate graph. Let me see if I can draw this graph better. So this seems like a better graph. Let's look at the critical points in this region. So here, notice here the x value is probably just above 7.5 approximately. The y value here, sorry, the y value is 8 approximately, and here the y value is approximately the same 8. Of course, it will have to be the same value because x and the y coordinate will have to be the same value. Now, if you add 8 plus 8, you get 16. Here is 0, 0. 0 plus 0 gives us 0. Here's the other critical point. This point is what? 20, 0. X is 20, y is 0. So the maximum possible value of x plus y will be 20. So here, the largest possible value of x plus y would be 20 based on the graph. When you add the x coordinate, and that's 20, 0. When you add the x coordinate and the y coordinate, you get 20. And the other critical point was 8, 8, of course. So 16, of course, is smaller than 20. So that's our solution. The table below shows pairs of values for the function y equal x squared plus x minus 4. On the grid, plot the remaining 4 points. Plot the remaining 4 points and draw the graph of the function y equal x squared plus x minus 4 for the domain x runs from minus 4 to positive 3. Alright, let's plot this graph. Alright, so the remaining points, let's see. So when x is negative 1, y is negative 4. We'll go back to the table. When x is 0, so 0, negative 4, 1, negative 2. So 0, negative 4, 1, negative 2. What are the other 2 points now? 2, 2, 1, 3, 8. So 2, 2, and 3, 8. Alright, and we should just connect this graph as best as we can. So so the graph should look something resembling that. Of course, it can be neater. But anyway, let's continue. What else are we asked to find? Well, write down the maximum or minimum value. Of course, this function, of course, has what we call a minimum value. Let's find the minimum value. So you'll notice the minimum value is about here. And of course, is it on the y-axis? That's about minus 4.25 or approximately there. So let's move to question 9. In the diagram below, as we can see, diagram a circle theorem problem. EG is the diameter, as we can see there. The tangent AEB, we can see this line. We have an angle AEC at 68 degrees, and EFD EFD, that's 106. So we're asked now to find some angles. The first angle we're asked to find is angle ECD. ECD, of course, ECD, of course, that's this angle. So notice this angle the line CFD is parallel to the line AAB. So if this is 68, then let me just extend this a little bit. Alright, this angle is also 68. So ECD is 68 degrees, and the reason alternate angles, right? So 68 here, this angle is alternate to this angle. Next, we are asked to find angle CEG. Angle CE, let's go back to the diagram. Angle CEG, that's which angle now? CEG, that's this angle. Notice from O to E, that's a radius, since G to E is diameter. So O to E is a radius. So the angle, and this line AEB is a tangent. So notice the angle between the tangent AE here and the radius here OE. The angle circled here and the angle between these two lines should be 90 degrees. So the value of this angle CEG would be equal to 90 minus 68, which is 22 degrees. So this angle would have to be 22 degrees, since both angles must add to give 90 degrees. We're also asked to find angle CGF. CGF is all of this angle. Now this angle, remember, angles on a straight line add to give 180. So this is 106, which means that this angle would have to be 74. Alright, notice the angles from, look at the segment CE. Angle running from segment CE, from the chord CE, runs to form here at F, 74. I remember angles from the same segment are equal, so CE, the angle from CE here to here would also be 74. Angles in the same segment, right? So this section would also be 74. Now you will notice the chord FE. An angle running from FE, from this segment FE, these two lines, F to C and E to C, so 68. Angle in the same segment FE, this would also be 68. So this angle CGF would be 74 plus 68, which works out to be, what's 70 plus 60, that's what, 130? And 130 plus 12, that's 142. So CGF will be 142 degrees. That's all of this angle. So part B, from a harbor H, a ship, the bearing of 2 points Q and R are 69 and 151 respectively. So let's deal with this. So 69, and then all of this will be 151. So this angle would be 151 minus 69. This angle would actually be 82 degrees, right? Same are 169. Sorry, 151 from the north of H. Alright, so Q is 175. Q is 175 kilometers from H. So 175 kilometers from H. while R is 242 kilometers from H. That's already in there. So we are asked to complete the diagram and find calculate QR. So of course we can use cosine rule to find QR. So QR square is equal to the other two sides square, which is 175 square plus 242 square minus 2 times these very same sides cos the angle between these sides, which is 82 degrees, which means that QR square, and we can do this on a calculator in one step. On the calculator we end up with 77401.04 or something like that. And if we take the square root of both sides, QR would be equal to the square root of 77401, which is 278 to the nearest kilometer. So this is 278 to the nearest kilometer. Next, we are asked to find, what else we are asked to find now? How far south is ship R from the harbor H? How far due south is ship R from the harbor H? You see, ship R, here's ship R. How far south? So of course you want this distance southwards. I'm not going on the south line. Here's H. If I go south, I mean south would be here. South is this direction, right? Opposite of north. Alright, so complete this. Alright. So one is southern distance. Well, let's call this X. The southern distance of R from H. Alright, let's see if we can get some angles here. So this is all angles in a straight line add to give 180, right? So this angle here is 69 plus 82. That's 151, which means that this angle would be 29 degrees. Remember, all these three angles must add to give 180, right? So if I think of this as a right angle triangle, now if I want the value of X, which is the distance south to R, if I want the value of X here, notice it's a right angle triangle, so X would be the adjacent. X would be the adjacent, right? And the hypotenuse would be 242. So I could use a cosine ratio and say cosine of 29 is the adjacent to this 29 here, which is X, upon the hypotenuse, which is 242. So if I multiply both sides by 242, or if I cross multiply, then X would be equal to 242 times the cosine of 29, and that will give us 242 times the cosine of 29. We end up with 211 or 212 to the nearest kilometer would be 212 kilometer. So this distance is 212 kilometer. So the answer to our question would be 212 kilometers. Let's move on to the final question. Vectors and matrices. Question 10. The product of these two matrices. So, let's do the product. So remember, when you multiply matrices, it's always rows by column. So you apply the 5, 4 to 2, 0, then 5, 4 to 1, 3, then the same 5, 4 to negative 4, 6. And then you apply the minus 3, minus 2 to the same 3 rows in the other matrix. And remember, when you multiply, it's always the first value times first value, second value times second value. So, and by the way, notice the first matrix is a 2 by 2. The other matrix is a 2 rows, right? And 3 columns. So you should end up with a 2 by 3 matrix, right? 2 rows and 3 columns. A matrix looking like the second one. So let's apply 5, 4 to 2, 0. So 5, 4 to 2, 0. So 5 times 2 plus 4 times 0. That's 10. Applying 5, 4 to 1, 3. 5 times 1 plus 4 times 3. That's what? 5 plus 12. That's 17. Then we're applying 5, 4 to negative 4, 6. So it's 5 times minus 4 plus 4 times 6. Now 5 times minus 4, that's negative 20 plus 24. That's 4, right? Then you apply the bottom row to the same 3 columns. So negative 3, negative 2 times 2, 0. That's negative 6. Then you apply to 1, 3. Negative 3, negative 2 times 1, 3. That's negative 3. Minus 6. That's minus 9. And then we apply bottom row to the negative 4, 6. We get positive 12. Minus 3 times minus 4. That's positive 12. Minus 12. That's 0. So that should be our answer. State why the two matrices are comfortable for multiplication, and the reason: the order of the first matrix is a 2 by 2, and the order of the second matrix is a 2 by 3. And if these two inner values are the same, then it's compatible. It should be easily can easily find the product of two such matrices. Part B, the inverse. So inverse of a matrix is 1 over determinant of the matrix times the adjoint of the matrix. Now what's the determinant? Determinant can cross multiply and subtract. So the determinant is multiply across, you get minus 10, minus and multiply across, you get minus 12. So it's minus 10 plus 12, that's positive 2. So the determinant is positive 2. The adjoint, the leading diagonal, switch elements, so minus 2 and minus and positive 5 switch places. And the other diagonal, the signs change signs. So this would be minus 4 and this would be positive 3. You can leave it like this, or you can multiply each term in the bracket by half. So half of that, that's minus 1. Half of minus 4, that's minus 2. Half of 3, that's 1.5. Half of 5, that's 2.5. Now, part C. The diagram below shows the triangle OAB, in which OA is equal to R and OB is equal, so OA is equal to R, as you can see, and OB is equal to S, as you can see. In addition, E is a midpoint of CD, such that OC is equal to 3/4 of OA, and AD is 2/3 of AB. Write in terms of R and S in its simplest form an expression for CD. So CD, let's deal with CD. So CD, the matrix CD, if you're at C and you want to get to D, then you can go from CD, you can go from C to A, so C to CD, so you can go from C to A and then A to D. Alright, to get from C to D, you can go C to A and then A to D. Now what is CA? Now CA, we are told, where is it? Notice CA, notice, I will give you CA. Notice we are told that OC is 3/4 of OA. So this is OC, so this is 3/4 of the way. So OC is 3/4 of the entire OA, which means CA is 1/4 of OA. So CA would be 1/4 of OA. And we know OA is R. So CA is 1/4 of R, right? So CA is 1/4 of OA, which is 1/4 of R. and AD is 2/3 of AB. So I think we need to find A. Let's find AB first. I think we'll need to find AB. Now the vector AB, to get from A to B, you'll go A to O, and then O to B. So A to O, notice, is the opposite of OA, so it's minus R, direction change, so the sign change. And OB, same direction as S, so negative R plus S. That's what AB is. Now AD, we are told, is 2/3 of AB. Alright, so A to D, so we're using this one, AD is 2/3 of AB. So AD is 2/3. AD, this A to D is 2/3 of whatever AB is, and AB here was negative R plus S. Let's try and simplify. So this is a quarter R. Expand, we get minus 2/3 R plus 2/3 S. 2/3 S, right? So a quarter, what's a quarter? So it's 2/3 S, let's put 2/3 S. And a quarter R minus 2/3 R. What's a quarter R minus 2/3 R? That's 3 minus 8. That's minus 5 upon 12. That seems like minus 5 upon 12 R. So that's CD. OE. Let's find OE. Oh no, too far. OE, to get from O to E, we can go O to C and then C to E. So OE, O to C and then C to D. And then O to E, O to C and then C to D. O to C and then C to E. So O to E, O to C and then C to E. So O to C and then C to E. Now what's OC? OC, I think we have OC. Did we find OC? I think we found OC, right? OC would have been 3/4 of R, because OA was R. So O to C would be 3/4 of R, right? 3/4 of OA. So it's 3/4 R. And then CE. CE, of course, is half of CD. Notice CE, we are told E is in the midpoint of CD. So CE is half of CD. Now, did we find CD? I think we did. It was CD, 2/3 S minus 5/12 R. So CE is half of CD, so it's half of CE, which is 2/3, sorry, CE is half of CD, which is half of 2/3 S minus 5/12 R. So we end up with 3/4 R, 1/3 times 2/3, that's 1/3 S, right? Sorry, half of 2/3, sorry, and half of 5/12, that's minus 5 upon 24 R. So if we group the R, so we have 3/4 R minus 5 over 24 R. Now what's 3/4 minus 5 over 24? So it's group, so it's 3/4. 3/4 is multiplied by 6, that's 18 over 24 minus 5. That's 13 over 24 R plus the points O, Q, and R have points. So O is 0, 0. Q is 5, 2. And R is, what's R? R is -1, +4, alright? As we can see, R -1, +4. Q is 5, 2, and O is 0, 0. Alright? Write OR as a column vector. So OR is same as the coordinate for R. OR is a position vector. OR, that's -1 and 4. Same as the coordinate. Determine the length of QR. Determine the length of QR. So first, to find the length of QR, of course, you have to find the vector QR first. And the vector QR is the coordinate R minus Q. Now, what are the coordinates of R? Coordinates of R were -1, 4. And the coordinates of Q was 5, 2. So -1, 4. -5, 2. We end up with -1 minus 5, that's -6. 4 take away 2, that's +2. So the modulus QR, we can use the formula as square root of x squared plus y squared, so it's square root. And the x is, so it's -6 squared plus 2 squared. So the square root of 36, 4 squared, 2 squared, that's what, 4. So the square root of 40. Alright, whatever that comes to, that should be about what, 6 point something. Alright, square root of 40. You can leave the answer in that form, what we call the third form. And that's the end of the exam. That's the end of exam. Alright, so this was the 2000, so the latest CSEC Maths exam, which was actually done on July 7th. Alright, so that's it. See you another time.